Okay, now moving on to the next question, 27th. The compound with two lone pair of electrons on the central atom are. Now BRF5, now because there are 5 fluorines, so we have 5 sigma bonds, and bromine has 7 electrons, so out of 7, 5 are utilized in sigma and 2 are left as lone pair. Not an option. ClF3, 7 valency, 3 are used in sigma and 4 remaining form 2 lone pair. Now this is a right answer. In XCF4, xenon has 8 valence electrons, 4 form sigma bond with the fluorine and rest 4 are residing at 2 lone pairs. Now in the SF6, sulfur has a valency of 6 electrons, 4 are used in sigma bond formation and 2 are left as 1 lone pair. So the answer is B and C. Next is the 28th. Now we have to find the reagent that can selectively precipitate sulfide from a mixture of sulfide and sulfate. Okay, now so we want something that has more tendency to form a sulfide precipitate than a sulfate precipitate. Now if you look at the values, now this is a typical question. It is not very easy to solve unless you have studied about the KSP values and you have solved some good problems on this topic. Now coming to the CuCl2, if you have copper 2 positive ions, now it will form copper 2 positive combined with the sulfide to form CuS. Now this has a KSP of around 10 raised to power minus 17, whereas the copper sulfate in hydrated form has a KSP of 32. So there is a huge difference. So we can say that this sulfide will be very easily precipitated because of its very low KSP value. So A should be the right answer. Coming to the BaCl2, we have barium 2 positive ions. Then if it forms BS, barium sulfide, then the KSP is 7.86, not very low. It is moderately soluble, not moderately but just not insoluble. And barium sulfate, it's also not very less soluble. So the difference between the values is not very large. So we should ignore this particular option. Now in the lead acetate, if it lead 2 positive forms PbS, then the KSP is around 10 raised to power minus 13 and the PbSO4 has 0.0043. So there again we have a huge difference in the KSP values. So this should also be able to react under the selective precipitation process. Okay, and in this case this is taken from the purification of organic compound. Now this combined with the S2 negative to form NOS here, that has a violet color formation. Now I'm not very sure about how it reacts with the sulfate and what will be the KSP for that. So I'll try to get the explanation for the last option, but as far I'm able to solve this question, the answer should be A and C because their KSP values differ by a very large amount in the sulfide and sulfate compounds. Now the next question, positive tolerance test. Now it's a trick question. They have asked some particular point here. Normally we know the tolerance test, it uses ammoniacal AgNO3. Okay, and finally the compound gets oxidized and Ag positive gets reduced to silver. That is why you see silver mirror at the bottom of the test tube. Now tolerance test is given by aldehydes because aldehydes are easily oxidized to carboxylate ions because this will be carried out in a basic medium. So in a basic medium you don't get carboxylic acid because acid will react with the base to form carboxylate ion. Okay, so this CHO part gets converted to COO negative part. Now B option, again we have a CHO, so it gets converted to COO negative carboxylate. Now here we don't have a aldehyde group, we have a alpha hydroxy ketone. Okay, now tolerance test is for aldehydes and also for easily oxidized compounds which are easily oxidized because here we are actually carrying out oxidation. So easily oxidized compounds include allylic alcohols. and also alpha hydroxy ketones. Okay, so in this case we have this one alpha hydroxy ketone. So this OH group is oxidized to form keto. So what is the product form in this case? In the C option, the product is alcoholic part becomes keto, and this is your benzyl. This is your benzoin. Okay, so this was a trick. The Tollens test is for aldehydes and also for the easily oxidized compound, which include allylic alcohols and alpha hydroxy ketones. Now the last one, it is not in these categories. It is neither aldehyde nor easily oxidizable compound, so this will not show. So the answer should be A, B and C. So moving on to the next question, 30th, the aniline. Okay, now this question number 30, I have simplified this. First step, we have aniline and acetic anhydride. So you can simply break this bond to form this electrophilic CH3CO positive, and this CH3CO negative and one H positive from here just are removed. So we get acetanilide NHCOCH3 as a product. Now why we need to form this? If you directly react this with Br2, then because of the strongly activating nature of the NH2, you get triple bromination at ortho and para. Now you don't want this. Okay, so how do you avoid that? You reduce the activating power of this NH2 by introducing this COCH3 group. Here the lone pair of the nitrogen is in cross conjugation. So sometime it is available with the benzene, sometime available with the keto group. So that is why the activating power is less. So this is less activated than aniline. So now the chances for a triple attack are totally gone. We'll have a single attack. So two options are there. Now this KBRO3 and HBr basically produce Br2 plus water. Now reaction with elemental boron is a little hazardous. That is why in the lab we don't directly use Br2. In the textbook it is given, okay, that is just for simplified version, that you just get reaction with the Br2, but in reality we are carrying out a reaction where Br2 is generated during the reaction. So this is the reaction, KBRO3 plus HBr generate Br2. So Br2 is generated in C2. Okay, so once Br2 is generated, we just have to carry out the bromination, electrophilic bromination. So NHCOCH3. Now since it's a bulky group, the ortho positions are sterically hindered. So the major product will be the para-bromo. Okay, so we don't need to draw the minor product, that will be the ortho. And finally, when you carry out the hydrolysis, acidic hydrolysis, the NHCOCH3 will again return back to original form. This COCH3 is removed. So what do you get again? You get an NH2 group here and we have a bromine. Now next is the NaNO2HCl 0 to 5 degrees Celsius. We know it is diazonium salt formation. So we have this N2 positive, Cl negative. Here we have this bromine and CuHBr. So obviously it is going to form Br here. So the answer will be second option, B option.